Welcome back. Where is my microphone? I'm very excited today. I thought I had already finished the session that we started to learn. I just brought probability and statistics as part of our studies in order to learn computer programming. And then I found that it is really very, very interesting to talk about probability and statistics because we cannot escape it in our life. And I talked about a lot of concepts and I did some practice and yeah, some exercises just to demonstrate our understanding of probability and statistics, hoping that people would also enjoy it the way I am enjoying it. And I know many people did because I got a lot of good comments. However, however, I have some questions to answer. So today is basically a Q&A time, question and answer time, because I had a lot of questions that I could not answer all of them, but I picked the key ones that I thought would really be very, 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 very important for us to understand and clarify our understanding. The first question was weird, though, that it is very, very concerning. To me, it is a big issue kind of question, which is very, very concerning. Someone said that, okay, that he never thought a black man had the big brain to reason things this far. Where are you from? Your origin, please. And then the second question is, what's the difference between statistical data and the rest of other data? The third question is, why mix statistics with other art subjects like history, economics, business, etc.? It is very confusing. And then the fourth question is, how can we use probability and statistics to um, understand the world around us? How can we do that? And then another question, I think there are five questions that I chose. Another one is, my question is, how can a mere statistics help us to understand the model for brain activities and atomic behavior? That that question is big, my friend. So, my friend, this is what teachers normally face, and as a lecturer or as a teacher, you get excited when question comes. When a question comes, or when they ask many questions like this, they come from all corners. Just be happy because people are willing to understand. And to me, I have similar feeling that all these students of mine who are asking these questions are really willing to understand, and I'm very happy to give you the answer. But before I go to start giving you any answer, I want to pray. I want to thank God to give me the wisdom. Give me the wisdom to handle these big questions. So let us bow down and pray. I'm going to start by thanking God. God, the Almighty God, I call your name because you are the greater God, the creator of heaven and earth. You are the supreme God. There's none like you. You are the creator of the heaven and earth and everything in it. You are the one who gave us everything that we have. Every atomic particles of our life or of anything that exists, Lord, came from you. You are the origin of everything. Lord, I pray that you give me the wisdom, the knowledge, and understanding to answer my viewers so that they also teach me, so that they also understand and share their experience with me. Lord, I thank you for this wonderful time because you gave me the knowledge to share and you gave me this time to share with others so that they can also share their knowledge with me in order for us to live as a human being. Father, you created human being to dominate the world and everything in it. You gave us the power, meaning that you gave us the knowledge to understand you Although we cannot be better than you, we cannot be above you. You're above everything, Lord. I thank you for giving us this power to dominate everything you have created for us, Lord. Lord, I pray that you continue giving us love, giving us life, giving us understanding, so that all mankind live as one people in this world without any segregation. We want to share our experience, our love together in order to move forward according to your will and your purpose. You have created us for your purpose, and I pray that you give me the strength, the energy to do your work and use me for your purpose to reach out to many people. And I pray that whoever is following me, whoever is interested in learning with me, Father, give that person the knowledge, the understanding, the wisdom that person needs in order to be with me, to teach me as well, because I am not claiming to know everything, Lord. I'm also learning. I'm willing to learn, I'm willing to listen, I'm willing to understand, and I'm willing, Father, to share my knowledge with others. Lord, I thank you. I cannot say everything, Father. You know all that I have in my heart, in my mind, in my body for you. And let me stop here by thanking you, the Lord Jesus Christ, our Lord. Thank you. My friend, it's not easy, but God has made it easy for us. So I'm going to start with the first question. Um, Let me see. The first question. I know I cannot give the name of the person who has asked this question, but let us get ready. I think you can see me now properly. Some questions were about how I do give the knowledge. They thought maybe I was reading everything from somewhere. How can I read? How can I read from somewhere? I was not reading actually. I'm giving you the knowledge because I've read books, I've studied, I've gone to different places, I've worked in the industries, and I have the knowledge to share with you, my friend. So the first question is about black man, my friend. I want to say that we are all the same, whether you're black, white, green, blue, whatever that color may be. We are all the same. We are all the same. God created us to be the same people on earth. We all have red blood, although God decorated us with different colors just to make the world to be more beautiful. And in my view, um, I think to say that somebody is black, white, or this and that is not really something which is pleasant. But I'm proud to be black. Be proud of being who you are. And about the brain, that is all from God as well. I cannot talk about whether somebody has big brain or small brain, but that is God's creation. And whoever has big brain or small brain, I don't know whether we can have the system to measure everyone's brain from a distance or to generalize everybody to be the same. And so the brain to reason things that far, that is God's creation. I just link everything to God because nobody can prove this apart from God. Where are you from? Well, that's a good question. We are all originated from God. Um, if you're asking me where I'm from in terms of my country, I'm originated from Uganda, and I'm proud of Uganda, and I'm proud of the president of Uganda. If I had power to make him one of the greatest philosophers in the world, I would add him to be among the three Greek triads. Those of Aristotle, Socrates, and Plato. I would put him there because he has done a lot for the country, particularly for myself as a as as a person from a war-torn area from northern Uganda. He did a lot to stop the war. and to rescue the children from the war and to create environment, for those who were abducted, without their intention to join the Lord Resistance Army, to come home and be free just like anyone else. That is the greatest achievement, and nobody will ever, ever, ever tell me that Seveni is a bad man, because if he was a bad man, all those children would have been killed. Everybody in the northern part of Uganda had this bad experience of the war, including myself. You know, I studied in that war, and I could not go to school. I sat my exam when the rain was raining, outside under the tree, you name it. But he managed to bring the country now back to life. So that's where I am from originally, my friend. And I think maybe if you have more questions regarding that, you can ask me. But, you know, I thank God for the security in the country of Uganda right now. The security. That is the greatest achievement. And also, I need to add on this, the president has opened up people's mind to start thinking that it is possible to prosper, whether you're educated or not, but taking education as the weapon of mass attraction of knowledge and understanding and progression. So, big credit for that. The rest are just bonuses. So, that's the first question. Now, let's go to the second question. The second question is about what's the difference between statistical data and the rest of other data? My friend, this question is very unique, very interesting. All the questions with the green background are really very, very good questions. And I hope you guys will understand a lot from these questions. They are very, very interesting indeed. And big credit, to you guys who asked me these questions, because you're interested to learn. So let us go through them. What's the difference between statistical data and and the rest of other data? Well, statistical data. But before I give you the difference between statistical data and the rest of other data, let me define what data is. Data is is I would say is a garbage. That's the best way. Data is a garbage until when you turn that garbage into a meaningful kind of thing, then it will become a source of information. So data alone on its own is meaningless. Anything can be data. Even myself, I'm a data. Whatever you're seeing behind me is data. Unless you assign the meaning to it, then yes, that data can become meaningful. So data will become a source of information when there is meaning attached to it. So that is what you need to take home from this question, that data on its own is meaningless. But when you link meaning to that data, it becomes a source of information. And information is now a consumable kind of item, because we consume information in order to add values in our life. Something which is meaningful is an information. So the difference between statistical data and the rest of other data is that statistical data are collected via some kind of experiment or some kind of observation. You can just sit there and watch people and, record something that you want to study, or you can go in the country and count the number of people when you want to learn about the population of the country, or you can listen to the radio and collect some data from what people are talking. You see, there are many kind of statistical data we have. Last time we look at qualitative data, which is just what I have described. Qualitative data, is about why and how things are happening. And we have quantitative data, which is about the number of things that you count, is quantitative. And we have continuous data, which is about the measurement or something which are continuously happening without, breaking. For example, when you're measuring the height of the students, the height of the tree, you name it, all those are, you know, continuous data. And we have what is called discrete data, which are fixed. You cannot separate them. For example, you may have like a sale figure for every day, daily sale figures. For example, you cannot say that today's sale figure is exactly the same as tomorrow's or yesterday's sale figure. So that is discrete data. It's all about statistical data. We have things like nominal data, data which you get through labeling things, like black, red, yellow. And we have ordinal data, which comes as a result of maybe ranking. When you're ranking things like, okay, this one has one, this one has two, that one that. And we have interval data, you know or ratio data, which are based on numbers exactly, but you know you have to you have to rationalize them. When something is smaller than the rest, or something is smaller than others, you have to compare things with that. So there are many type of statistical data. you know and then other datas are just like anything that you can think of. There are other data. So statistical data are collected from some kind of experiment or observation in order to achieve some target goal. For example, if you want to know the name of the population, I mean the size of the population, you want to learn maybe the impact of something over another, you know, you need to observe, you need to do some kind of experiment and then collect those kind of data. Those data are statistical data. But the rest of the data are just anything that has no meaning. That's the difference. Statistical data are linked to some kind of meaning beforehand, but other data are not linked to meaning. You need to link meaning to them and then make them to become statistical data in order for you to kind of like start uh, making sense of them. So I hope that clarifies the difference between statistical data and the rest of data. Let us go to question number 3. Why mix statistics with other art subjects like history, economics, businesses, and it is really very confusing. My friend, I think I'm getting somewhere where the questions are really getting interesting. Let me get ready. Let me get ready to answer. I'm going to take my shirt off. This is really interesting. Very interesting indeed. Very interesting. The question are really getting very interesting indeed, my friend. So let's face it. Hmm? Let us face it now. I like the person who asked this question. It's really very interesting. Why mix statistical um, why mix statistical data or statistics as a subject with the rest of other subjects? It is really confusing indeed. That is the question. My friend, I just want to start by thanking you for asking me this question. But Let me start by saying that statistics or probability and statistics are combined together as one because they are very, very, very important in our life. We cannot do without them. In fact, the knowledge you have in your brain is the collection of data that you collected right away from the time of conception up to now. That is statistics. And that's how important it is for you to now analyze this data and start recalling what happened, or when you see something that you saw in the past and then remember that, oh, I saw something, oh, this is that, oh, that is that. Probability comes there because you now relate the chance of having seen something in the past and then recalling the data that you have collected in your mind in order for you to know what is happening. So that is basically statistics. And it is not an art. Statistic is a branch of science and mathematics which deals with the collection of data, organizing those data, analyzing the data, interpreting the data, and presenting that data in a meaningful way so that people can consume as information. The main objective for doing that is to learn the patterns in that data so that we can make a prediction from that pattern, what will happen next, or learn about what might have already happened back in the past in order for us to make decision. That is what statistics, what probability and statistics help us with as a branch of science and mathematics. But they are all sciences. Now, when you talk about art subjects like history, economics, and businesses, I related statistic or statistics to those area because you cannot do history without data. You cannot do history without the past. Histories or history is the collection of the past event. Without the collection of the past event, history would not exist. And to collect those past events, in essence, is exercising statistics, probability and statistics, to learn what happened in the past. And for things to build up, they must occur. That's why I describe probability as the chance of events occurrence in a given series of trials. When things build up, it creates a remarkable basis on which we can make decisions based on the occurrences of those things, whether the same thing is likely to happen again, or whether it happened, or whether it is happening now. So the collection of those things give us a remarkable basis on which we can now derive probability from, and we can now start learning statistics from those data. That is what history is all about. And for things to move like that, I told you that statistics and probability help us to understand the arrow of time thermodynamically. You see, thermodynamics, when you study thermodynamics, I'm not going to go deep into that. I would refer that to the physics guys, but things which increase thermodynamically, meaning that once something happen, you cannot get rid of it. Another things will come and add on top. The rest add on top. The rest add on top. And that is how the world is built. That is how the universe is built. from the Big Bang, from the time of quantum fluctuation to the time of where we are right now. And the expansion is still continuing. That is why the Big Bang theory is inconclusive. So everything is building based on the historical perspective. Because if the history was not there, nothing would be sitting on it. So the accumulation of information help us to understand what is happening or what had happened. And I refer that to the entropy of information, the collection of ordered or unordered data, which built up to create a historical perspective of something on which we can rely on to predict the future or to know the current situation or to bring us to the current situation. We are the history from the point of conception up to now. We are growing. We know that, you know, before we were conceived, maybe God created us somewhere. Those who believe in God, like me, you know. And then after the conception, we started growing up, building up. Each time we grew up from the womb until when we came out, we are making history, my friend. Up to now, we are still making it thermodynamically. So you cannot do that without statistics. That is why I was giving that as an example to justify what statistics really mean, the collection of information. You know, although I said in the previous question that it is the kind of data, the statistical data exactly, something collected experimentally or as a result of observation with a given target. I think it is prudent to say that we are also the target of something, some of God. God created us with limited time on earth. We have the limited time to live. Nobody can live for more than 130 years. The time is limited. So the target is there. So statistically, we started or we start growing from the womb until when we die. And then after that, maybe those who believe in God, like me, we will have what is called eternal life. Because this body here can vanish. I will now explain something that I should have not even started. This body is full of chemicals, and these chemicals are full of matter, atomic elements, and this element is full of, like, for example, they say that I'm just referring to what scientists say or doctors. The body is 80% full of water. And you know water, you know what is made of water? Water is the combination of two gases. When you combine hydrogen and oxygen, you get water. Meaning that when we die, the water will dry up and we turn up to that gas. And so at least we have that kind of the soul, that kind of the remain in terms of gas after our death. That's why they say there's life after death. You know, the gas will just blow away because our body is full of hydrogen and oxygen, which are gases combined to form the water which is in our body. I'm going to talk about that when we are when I start discussing the rest of the question concerning the behavior of an atom or the atomic behavior. So statistics is the study of the relationship between between two or more things, between two or more data, but it involves the collection of data, organizing the data, analyzing that data, interpreting it, then present it in a meaningful way, because the target is to create meaning to data so that we can turn it into some kind of information, right? For us to make decision, to do prediction, to learn, to do the pattern analysis. That is what statistics is all about. And you cannot do history, economics, and businesses without the analysis, without the data. Economics is the social science. You see, when I say art subjects does not exist, some people may say, wow, this guy is crazy. I'm not crazy. Let me justify. We only have sciences. Whether you do history, whether you do economics, whether you do business, whether you do law, whether you do psychology, whether you do sociology, whether you do anthropology, you name it, all those are social sciences. But we have what is called physical and natural sciences, which comprises of things like chemistry, biology, mathematics, and physics. Those are hard sciences, hard part of sciences. Things to do with economics, history, law, sociology, psychology, anthropology, they are all parts of what I call social sciences. So we have social sciences and we have hard sciences, which are physical, natural, and life sciences. Now, arts is a way to articulate the ideas. Yeah. The, the idea we have may be scientific idea, or as you say, artistical or artistic idea. But you need to articulate the idea to turn it into reality. So the soft science, which I call it social science, is the soft part of science. Just like computer had hardware and software. You cannot see, you cannot touch the software. For example, the operating system, you cannot touch it, but it is powerful. The operating system is used to control all other applications in it, and it is used to control the hardware. Similarly, with social sciences, the subjects that we have there, when you study them, it gives you the ability, or they give you the ability to control or to develop the system. The system could be the government system, could be the system of management, could be the system of coming up with the organizational policy, could be the pricing system. You see, something that you can see its impact, something that can become tangible. The system of controlling people, the system of employing people, the system of training people, the system of training machine. Yeah. So they are all social sciences. So social sciences are the academic discipline, or I would say that social sciences are focused on the study of human society, the study of humans and their society, plus their behavior and the relationship between them in order to make the world a better place. That's social sciences. And things like economics, businesses, history, arts, um, anthropology, which is the study of culture and the relationship between society, anthropology, psychology, sociology, economics, they're all geared to study human behavior, to study human society, to study the relationship between human beings in order to solve complex societal problem. in a society, to make life better, to improve life, to ensure that people grow and develop as human beings who know how to allocate resources to help themselves and help others. So you cannot do all that without statistics. So the social science, get it right, the social sciences are like the operating system which is used to control the hardware, which are the physical sciences, the physics, the chemistry, the biology, the mathematics, philosophy. Yeah, you use your artistic artistic knowledge to articulate the idea in order to do sciences. So without arts, as you say, it's not arts. Without social sciences, hard physical and life sciences will not exist because we have to have the ability to articulate them. So in essence, whether you studied economics, whether you study history, whether you study business, whether you study politics, all those are social sciences. You can use the same knowledge to do hard sciences because you have the ability to articulate ideas in order to turn it into reality. That is why I was giving them, I'm not mix, it may sound like a mix, but they're all sciences. So I use history, economics, and business as the best example to emphasize the application of probability and statistics in order for us to understand statistics and probability practically, because we can apply statistics in economics and businesses in order to make sense, to understand what is happening around us, to make choices, to make decisions, to succeed in life. So economics is the social science which deals with the study of how individuals, businesses, government, organizations make choices under hot situation, under scarcity, in order for them to be able to utilize the limited resources in order to satisfy unlimited want. That is economics for you, my friend. You have human beings have to survive in hard situation, and in order for us to survive, we have to learn economics. We have to know economics by all means. That is why most governments around the world, they focus on economics as the heart of their political behavior. Politics cannot do without economics because they are all about making choices, making decisions in hard situation. And the main target for that is to be able to make people to prosper. Prosperity cannot come without economics. You know, the target is also to create economic growth and development. The target is also to be able to understand scarcity and the opportunity costs. And above all, is to realize the beauty that economics brings. That is the incentive. When you manage to utilize the limited resources in time of scarcity to satisfy unlimited wants, the wants cannot be satisfied. But with the few resources that we have, if we can manage to use it within our means and survive, we can now call ourselves a success, or we can crown ourselves to be successful in that context. So, statistics help us in mobilizing all those. So, the target for economics is to create prosperity, to promote economic growth and development, and to understand the incentives that we as individual or as government can get from economics. And we cannot do that without statistics and probability, because it's all about choices. We have to be able to make choices under difficult situation. And to make that choice, you need to know the data. Make sure the data are there concerning the economics. Make sure you know how to organize them. Make sure you know how to analyze them. Make sure you know how to interpret them in order to present them to make that kind of choice. There's a strong correlation there, my friend. So we have concept like micro or macroeconomics. You know, microeconomics deals with the study of how individuals, small firms, make choices, with their life, how the pricing or the purchasing power of individual is measured. And when you talk about labor force, you go and talk about microeconomics, but macroeconomics deals with the much bigger aspect of economics, which looks at the wider, you know, it looks at the global level, it looks at the global level of development instead of individual or just small group of people. It focuses on things like unemployment, inflation, income inequality or inequality, growth, national income, growth and development. That is what macroeconomics focuses on. But all macro and microeconomics are all important. They are all important because they are all done with the main aim to understand scarcity, to understand the opportunity costs, to understand the incentives and the market mechanism or market force of demand and supply in the country, in order for the government, for the individuals, for the organization, for businesses to make proper choice to survive during time of scarcity with the limited resources to satisfy unlimited ones. That is economics, and you can't do that without statistics. Even business, economics actually sit inside business. You cannot do business. Some of you are doing businesses. They're doing businesses without knowing that you're practicing economics implicitly, even if you did not study or you don't study or you have no knowledge of economics. You're practicing economics implicitly because business is the study. I will not say the study. Hmm? Businesses are entities. They are now like item. They are entities. Businesses are organizations or enterprising entities formed to perform the activities of production, buying, and selling of goods and services with the aim of making profit. Because the main aim of business is to be able to make profit. That is number one. And you cannot make profit if you don't know how many items you are going to sell, or how many items you are going to produce, or how many, what is the demand and supply in the market. That is economics. You can't do that without knowing those information. So the main aim of the business is to maximize profit. Secondly, the main aim of the business, apart from profit, is to survive during time of scarcity. So to survive, the business must be able to produce goods and services for its customer. Must produce. If you don't produce, you will not survive. Apart from that, the production of goods and services, you must aim at being continuously existing in the market. You cannot just do business for one day and then you say that is it. You need to aim at existing, at prevailing every now and then to continue with your businesses. Apart from that, the survival techniques is to be able to contain, to attract more customers. You need to have what is called social responsibilities. Be able to let the customer feel they are contributing something by being your customers, not only buying things from you. Value your customer, because without the customers, your business will not exist, my friend. Where will you sell your goods and services if the customers are not there? Where? So, the fifth things, which is I would call the big blow, is that any enterprising activities or any business activity or any organization that calls itself a business, or any individual who calls himself or herself a businessman or woman, you must be able to take risk to produce in time of scarcity, risk to continue surviving. You must take risk to do business. And for you to be able to do all that, my friend, without any data, you cannot survive. You have to collect data, and that depends on probability and statistics. That is why, my friend, I mixed this subject, because they are logically everything boils down to statistics. It's all about decision making. It's all about looking at the patterns of demand and supply in the market, looking at, you know, the way to predict what the future will be like, how to survive in times of uncertainty, in times of scarcity. How can we survive? How do we know that scarcity exists in the first place? We have to have some knowledge, and knowledge comes from experience. And experience comes from the collection of the individual data that I told you about. That we begin collecting data from the time of our conception up to now. So all those data we collected will form the memory, the basic information that we have in order for us to progress. We have to recall what we have in our memory to assess the situation, to make decision, to survive. That is how probability and statistics are important. We cannot do without them, my friend. And that's why I decided to put history, economics, and business as an example to justify uh, the concept of probability and statistics. Especially, we did descriptive statistics more than um, inferential statistics, and to understand the economic situation, things like mean, median, mode, standard deviation, variances, box plot will give you the assessment of the market situation to see the volatility of price, to see what is happening in the market with demand and supply, the shortages, the scarcity. You have to learn that from statistics, my friend. So that answers that question. I know I could talk until tomorrow because this is the most interesting area of this study. But remember, I'm doing all this because I'm linking this to computer programming because computer programming is not far from human being. And if human being can base their understanding, their analysis, their knowledge on statistics and probability, what about computer? It means computer also base its understanding on probability and statistics. For it to work, for a program to run, it has to to have some kind of data. There must be some kind of information given to it in order for a given program to run. Even the AI system, we are now talking about artificial intelligence, what is it? It's all about program, and they cannot run without data. They can't work without data. So the accuracy of any system depends on the accuracy of the data we give it. So don't rely on any AI system that, oh, I'm using the AI. They just go and collect garbage on the internet based on your request and boom, they give it to you. Then you say, oh, it's from AI. This thing is correct. Wapi is not correct, my friend. It's not correct. So rely on your knowledge first, then use other sources as the supplement, you know, to supplement your knowledge. So we are going to the fourth question now. I'm trying to be brief because this is really something that is something that I must emphasize on. How can we use probability and statistics to understand the world around us? My friend, I'm not a physician or a physicist. Yeah. So I'm just going to refer you to go and study a lot concerning many theories which are out there. We have things like theory of relativity, both by Newton and Albert Einstein. They came up with the theory to study the existence of the universe. So, in a nutshell, I just want you to realize that for you to really make the next move, you must have recalled something from your mind or your brain, or your eye must have seen something. You have collected, analyzed, and assessed the situation in order to move. My friend, that is probability and statistics. You cannot see fire and then say, I'm going to jump there. You know that the fire is hot from your previous experience. If you had not tested it before, you may jump and get new experience. But if you knew that fire is hot, that means at some point you got burned or you got some heat from fire. Then you know that the fire is actually hot. Statistically, you have collected the information, stored it, kept it in order to infer what would happen if you decided to go and jump in the fire. That's probability and statistics in the making. Now, let us try to apply theory of relativity. I'm not going to go deep into the theory of relativity, but there's what is called theory of relativity, which was brought by Newton to study the forces that led to the creation of the universe, if you like. We have Newtonian theory of relativity, which talks more about the gravitational force and talk about the time and space as being absolute. But Einstein came with his theory of relativity, which actually talks about time and space as being one thing. So that theory overrides the Newtonian theory of relativity. And from that theory of relativity, um, there's what is called special relativity that Einstein came with it in 1905, I think, which studies time and space as one, and that the speed of light is constant, it will never change. And the light can only escape any object by bending. When the light comes to hit this object, the light is not going to go through. It is going to bend up, right, sideways, down in order to escape and go. And the speed of that light is constant. So that led to the general relativity, which talks about the gravity, that gravitational force does not exist. Gravity is formed as a result of the curvature of the space time. So try to read a theory of relativity, then you will understand that the Big Bang theory, which tries to explain the existence of the universe, was not caused from nowhere. It came as a result of a build up of some kind of energy. And that theory that led to the Big Bang theory was also beyond the theory of relativity, because theory of relativity talks about the physical existence of the universe, the physical explosion, expansion of the universe. From the theory of inflation, we have the theory of expansion. After the Big Bang, the universe started expanding, and the expansion is still taking place up to now. The universe is expanding endlessly. That's why the Big Bang theory is inconclusive. If you are any scientist, you can now tell me where the Big Bang theory is terminated to say that this is it. It's not conclusive, because the expansion is continuous. Why? Nobody knows. So the theory of quantum fluctuation explains the existence of some probabilistic force that led to the explosion of the universe. That probabilistic force is not physical. That's why I said everything must have two parts. We have social science, which is not physical, and we have physical sciences, which are physical. And the physical cannot work without social, without and physical, without the semantic one. The operating system is there to control the hardware, and the hardware is there to run the operating system. So they work together. Similarly, we have the theory of quantum fluctuation, which explains the existence of the universe, that the universe pre existed by some kind of force, the natural force, and that force is probabilistic, some kind of probabilistic energy that led to the creation of the spike and bang, the Big Bang, and then the expansion and inflation began after that. And it happened at the microscopic level, smaller than an atom. So that is how probability and statistics help us to understand the world around us. Backdating to the quantum fluctuation and probabilistic energy, which was not physical, that led to the physical realism of the universe we are living in. So that is based on scientific studies out there. I mentioned Einstein theory of relativity, and then go and read about the Big Bang theory. It's not my work, but you can go out there and read about them. Read about the fluctuation, the quantum fluctuation. Read about the natural force that led to the creation of the physical force, which brought about the Big Bang theory and the theory of expansion, hence the theory of relativity. So, all this would have not happened if that natural force, which is non physical, my friend, that is the point where we can ask big question like what is the power behind the probabilistic energy that led to the Big Bang? What is the power? That is the point. Me, myself, I believe that God exists from that point. That's the strong evidence for me to believe that God is there. There is something beyond science. And it is the source of my belief that God is there. We have to pray Him. He is the creator of the universe and the earth and everything in it. That is why I started that as my prayer, so that you know that we are not just existing. I know some scientists or some people will say, if God is there, why God cannot cure cancer? Why God cannot provide this? God has already created everything there in abundance. I will show you in the molecular calculations that we are going to do to conclude this, how our atomic elements are there in abundance for scientists to use. We have what is called periodic table in chemistry that contains all the atomic elements with their atomic masses and their uh, atomic number to identify them. Everything was not created by any scientist. It's already there in abundance. Scientists are there to learn about them, and we have to thank God for giving us that ability to learn about what He has created for us. And the more we acknowledge that, the more we thank God, the more we will discover even more things. And it may even lead to the discovery of the cure or the treatment of major diseases if we put God first. But now, because of the little opening of knowledge that God gave us, some people think they are God. What a shame. So let me not go that far. So statistics and probability help us to understand the world around us in that sense. Now let us go to the last. I know time is running out. Um, Time is running out. I need to speak to my wife as well. Now, somebody says, my question is, how can a mere statistics help us to understand the model for brain activities and atomic behavior? My friend, this is deep. My friend, I've just explained in question 4 similar kind of thing. That part should be part of this question. So the answer to question 4 is part of the answer to question 5. But let me add on how probability help us to understand the model for brain activities. Yes, probability and statistics help us to design mathematical model of brain's activity. There's what is called statistical physics, which help us to understand how the neurons are being fired from the brain between the cells and all over our body. The cells intercell communication take place via the nerves, via the neurons, the electrical signal. So probability and statistics help us to understand the common behavior of that neuron, if you like. And that common behavior can be worked by finding their average, the average firing of the neuron and their synchrony in the genomic system as a result of the brain activity. So the mathematical model is built. You can go on the internet and search for that. There are people, scientists have discovered that. So in that context, probability and statistics plays a great role in the development of the mathematical model of the brain activity by understanding the rate of firing of the neurons and their synchrony, their synchronization based on their occurrences in the genomic system. Also, probability and statistics help us to design the model for the brain activity by understanding the the movement or the commonality or the behavior of the cell. How do they behave? How do they vibrate? How do they communicate? There's what is called di. I would say I should not bring it here right now. I know it's very hard to understand. We normally use it in machine learning. Um, anyway, let me not go that far because I may confuse you. Dimensionality reduction. Yeah, the theory of dimensionality reductivity or reduction is also applicable as a model for understanding the brain activity. By using that theory, we can be able to understand the common behavior of the cell based on statistical uh, data in the genomic system. Now, when I talk about cell, some people may think like, what is cell? To understand cell, my friend, you need to understand the atom. And we say probability and statistics help us to understand the atomic behavior. An atom is the smallest particle of matter. Matter is the existence of the physical things that we see. I talk about the theory of explosion, and the world explode at the microscopic level, smaller than an atom, meaning that we are living inside the atom. If the Big Bang happened at the microscopic level, an atom can only be seen by using microscope. And the Big Bang took place inside something which is smaller than an atom. Then we are inside an atom. That is logic. The whole world is inside an atom. Now, how can we understand the behavior of the atomic particles? So if an atom is the smallest particle of matter, matter is the physical thing that we are seeing now. So my body is full of matter. Any object that you see is the combination of those small particles. So those small particles form what is called molecules. Molecules consist of two or more atoms of those small things. Now, when those small things combine together and they combine, they combine together, they form what is called compound. And compound is full of the atomic elements. That is chemistry for you. So, what are those atomic elements? Atomic elements are things like, you name it, go to the periodic table. All those are atomic elements. And our body is the matter, is the combination of those atomic elements. And those atomic elements lead to the formation of our cell. We have what is called DNA, deoxyribonucleic acid, which is like the Bible of our life. Deoxynucleic acid is an atomic element containing molecules for the development of our life, containing atomic elements that contain the information about us, information about our growth, our development, our reproduction, the genomic system, the chromosome. When you talk about the chromosome, think about the gene. The gene is that information, which is our DNA. So probability and statistics help us to understand the genomic system, the atomic behavior, how our body is built up. Statistically, maybe we started building by one atom, but one atom is not enough. We need at least two as molecule. Then two molecules are not enough. More are formed to make compound in order to build up our body or anything that we can see physically. Otherwise, we would not be able to see anything using our naked eye at the level of atom, because atom is microscopic as well. So it has to build up a lot of atomic elements in order for us to see as a compound. Compound is the combination of millions and billions of zillions of atomic elements that we see forming the cell that we see our body cell. So an atom, an atom has what is called proton and neutron inside, and proton and neutron makes what is called the nucleus of an atom. They are found inside. Let me see how I can demonstrate this. So I'm talking about atomic elements. Atom is a small particle, microscopic particle that we cannot see, which makes up the matter. So inside the atom, we have the nucleus there. You have the nucleus. I don't know whether the spelling is. We have the nucleus of an atom. And this nucleus is proton and neutron. They are found inside atom and they are positively charged inside there. And then outside an atom, we have what is called electron, which is negatively charged. Electrons react with the protons and neutrons in order for the cell to reproduce another one, and reacts in order to produce another one. Reacts like that. So reaction come as a result of what is called bonding. There's what is called bonding. Yeah. We have what is called covalent bond, and we have ionic bond. So when two or more atoms combine together, they form molecules. And when more molecules combine together, they form what is called compound. So we have different types of compound. Yeah. We have ionic compound. We have covalent compound, which forms as a result of this acid only. We have ionic, which is the mixture of the two, like acid metallic elements combine with non-metallic elements to form another element. And we have intermetallic elements, intermetallic compound, which is the metal that you can see the small, um, when you see the metal and the metal, we have like strong metal. That is what intermetallic uh, compound is, bonding. Yeah, we have ionic and non-ionic, the mixture between two elements to form another element. For example, what can I give as example of the compound that can be bonded with another? We have chlorine. Chlorine is a poisonous gas, and we have sodium, which is a reactive metal. So when you mix sodium and chlorine together, it forms what is called sodium chloride. And the sodium chloride now is another compound. And that is the salt, the table salt we use for eating. That is the example of how atomic particles react to form one another. Another one for covalent bonding, let me for non-ionic compound, I can say water. We have two gases, yeah? We have hydrogen and oxygen. Now, when you combine those two gases, when you combine hydrogen and oxygen, you will get HO2. And that HO2 is water. Water is non-metallic. It's non-metallic. It's a liquid. So we are mixing gas and gas to form liquid. That's why I said when we die, our body vanish. It goes in the air as gas because the water has to dry and death occur because our cell needs water, our cell need food, our cell need all those kind of things. So when those things have been released from the cell, the gas will vanish. That's why you don't see when somebody dies, you just bury there, the body there, and the gas, whew, the body will rot and go to the soil. That's why they say we have soul, we have our soul in form of gas that we cannot see. That is an ending life. It's distinct because of the DNA. What is inside the DNA is an atom that defines each and every one of us. Deoxynucleic acid. That's why that is to me, if anybody asks me about God, I would say God is inside there. Because that DNA contains the genetic information about us. It has to be decoded by what is called RNA. RNA stands for ribonucleic acid. It's another acid, it's a molecule that contains two or more atoms. That acid has to go inside DNA, trans, you know, transcribe it. It has to go and collect the information from the DNA, bring it out to the cell, which also has its own DNA. Because I told you that DNA replicates. Yeah. So ribonucleic acid go inside, grab the information, and it decodes, it encodes, and it translates the DNA information into the protein, into the information that can be turned into the protein for cell development. So statistics help us to understand that behavior. How many times cell can replicate? What can lead to the replication of cell? We need one or more atoms in order for cell to replicate. And cell replicate via bonding, ionic bond or covalent bonding between metal and metal or between non-metallic elements. So cell replicate like that. The bonding continues, and that is what is happening with the universe. The expansion is continuous because of the bonding that is taking place. We don't see the explosion, but the expansion of the universe is continuous. But it began from somewhere. And that somewhere is some kind of probabilistic energy that came randomly. And who knows the source of that energy if God is not there? Challenge me. If you're a scientist who knows the source, come and tell me. I'm here. Come and challenge me. Tell me the source of that energy that led to the Big Bang to occur. Where is that energy coming from? Or where is the source of that energy? Where is the source of that source of the source of that energy that created the Big Bang? Or where is the source of the DNA information that we have? The chromosome that contains the information about us. Who put that information there inside the atom? If not God, my friend. Who? So nucleic acid is used to decode, to encode, to translate the DNA information for protein synthesis. So it brings that information and drop it into the cytoplasm. Now fetch that information and drop some amino acid there, and that lead to the development of to manufacture the protein. So we have three types of RNA. We have the messenger that goes inside the DNA to fetch the information, and we have the transfer which is tRNA, whose work is to drop the amino acid on the information fetched by the messenger, and we have the ribosomal um, NRA, which is used for now assembling and manufacturing the protein that can be used by the cell for the cell to replicate. That's why I say the virus attack the cell to invade the cell, because virus is the parasite, is the intercellular parasite, intra and not just inter, because the viruses attack the DNA, attack the cell to go and sit there in order to cut the communication between the DNA and the ribonucleic acid, so that cell cannot get the information for replication, and cells dies, it bursts up and we end up dying. That is why it is very hard to find cure for virus, because virus cannot live on its own. It has to go and survive inside the cell and use the cell as its genomic system. I hear people talk about NRA virus. No, NRA is not a virus. NRA is a physical process. Nucleic acid, ribonucleic acid, is the way God created the DNA to communicate in order for our cell replication and replication, because the protein has to be manufactured in the cell for cell to replicate, to be able to create chemicals for bonding. I'm not I'm You go and study, go, there are many books there, there are many medical students out there, there are many doctors there who can explain this to you. If I'm lying, please, I'm here. If there's no such a thing as DNA, let me know. If DNA does not contain genomic system or the gene, let me know. Gene is the chromosome. The chromosome is full of gene, and that gene is full of DNA, which contains the manual of our life. It is an acid, is microscopic, it's an atom. You have to see using my microscope. Our naked eye cannot see. So the cell has to build up that atom molecules. That atom builds into molecule which contains one or two atoms to build into compound. And once it is a compound, now we can see, because compound comprises of different kind of elements now. Different kind of elements that you see in the periodic table. So when you hear that somebody is sick, it could be that some virus has destroyed the lining of the DNA. DNA is two strand, and RNA is only one strand. Their makeup is completely different, but RNA is the one that has access inside the DNA to fetch the information, and that information now will be translated into the protein, manufactured into the protein that will be used by the cell to develop and replicate to another cell, forming this compound, like me and you, or this thing here. But different kind of compound leads to different kind of uh, formation of things. Like the compound that is formed of me, we know that 90%, 80%, or 75 to 80% of human body is full of water, meaning that our body comprises of the highest percentage of non-ionic or non-metallic element. Non-metallic element, 80% of our body is full of water. Water comes as a result of the combination of two gases, hydrogen and oxygen combined together to form liquid, and that liquid is water. So that combination is the bonding I'm talking about. For them to combine, there must be some protein that facilitate that binding process. So for our body to continue binding like that, for our cell to continue existing healthily, the ribonucleic acid has to be continuously communicating with the DNA, fetching the information, and then cell has to be able to manufacture the protein that can be used by itself to replicate, to maintain its shape, to maintain its natural health, for us to continue living healthily and jumping. Once the virus hit one cell, once the virus hit one cell, that's it, my friend. Because cell replicate, it will now replicate with the virus. And the genomic system of the virus will now be the genomic system of the cell. Hence, if we don't have strong immune system, the defined system, that virus will now make the cell dormant, make the cell inactive, simply because there's a cut-off between DNA and nucleic acid to manufacture protein for the reproduction of the cell. So the cell will now burst up, boom, and then we are dead. So probability and statistic help us to understand that process, that atomic behavior I'm trying to explain. I'm a researcher. I did the research. That is why I'm talking from the experience. I did my PhD thesis was in gene interaction. I studied the interaction between the gene to design the machine learning to learn the behavior of the cellular, intercellular, intracellular communication. That's why I got the experience from. So I speak boldly, and if you're there, you can challenge me because I know this behavior. I saw it, I witnessed it. So the only way to protect our body is to build strong immune system. The immune system to defend, to protect ourselves, so that whenever any virus comes around, our immune system will clear it before they go inside the cell. Even when they go inside the cell, the strong immune system can still be used to cut the communication between the virus and the RNA, the messenger, the transfer, and the ribosomal RNA. so that it carries with its work to fetch the information from the DNA for the protein synthesis for the cell to continue multiplying, although the virus may be inside, simply because of the strong immune system, even within the cell itself. Otherwise, if the immune system is not strong, that virus will cause disorganization in the cell, and the cell will not communicate among themselves. Replication will stop, cell will die, RNA will not contact the DNA to get the information for the protein synthesis and will die. So I'm not a doctor, but the doctor will be able to talk about that. But if you're interested in the research using probability to understand the behavior of the cell, I'm here. I'm very much willing to join your research team to further this kind of study so that we can understand the behavior of our genomic system together. I'm here. If you want to challenge me, I'm here as well to defend myself. So I'm talking a lot because this is a very interesting question that led maybe to the development of mankind and every compound that you see. So I'm just going to give you some example to show you that atom is in abundance. God has already made it in abundance. There's no, there's no, there's no, there's no scientist who claim to be the creator of an atom. That's why we have atomic elements for the scientists to study this thing, to understand their behavior, and probability and statistics help us to understand this thing further, to understand the replication of cell, to understand the viruses. Because when viruses attack the cell, they change the genetic makeup of the cell every now and then. That's why it's hard to treat them. If you want to treat somebody with the virus or to treat that virus, you need to kill the cell. And when you kill the cell, that means you're killing the person. So I talk about mutation, that the viruses mutate, change its shape. I did not mean its physical shape. The shape that the viruses change is the genetic makeup. Because when they are now replicating inside the cell, they confuse the normal reproduction of the cell, because now the genetic material for the DNA that God has originated for us now becomes the property of the virus. Now the virus now replicate and change, keep on changing its shape. I mean, its DNA makeup keeps on changing. Today, if you get the treatment for the DNA makeup for the virus today, tomorrow it may change to something else. Your treatment now will be useless. Tomorrow we have a different shape, you have a different makeup. The next day, a different makeup. That change could take place in a millisecond or microsecond, or making it hard to get treatment for virus. But now, how can we use probability and statistics to understand the rate of change of the genetic makeup of the virus inside the cell? That's a big question. It's a research question. I'm here to join that team. If you are that team doing research, to apply mathematical and probabilistic statistics to learn about the genomic system in order to understand the behavior of our cell linking to the atomic particles. Contact me if you're watching this video and you are interested in that research. I'm with you. So thank you for viewing.